Hi everyone, this is Manas, your friend and tutor. And guys, today's session is going to be based on Helix. We'll basically have planned 4 videos for this series on helical curves, and we're going to start off today's session by learning how a cylindrical helix can be constructed. This is going to be followed by helical spring of a wire having a square cross section, of a wire having a circular cross section, and we'll wind up the entire session by learning the demonstration or how the construction of a conical helix is done. But first of all, let us try to understand what exactly is the meaning of a cylindrical helix. Let us try to read the definition. Here we go. So it is basically a curve generated by a point moving around the surface of a cylinder. Okay, right now let's focus on cylinder. So it's a point which is moving around the surface of a cylinder in such a way that its axial advance, very important term, in such a way that its axial advance is uniform. So this is something that you really need to focus on. Now let me just make the front and top view of a cylinder, and here we go. The cylinder in fact looks like a rectangle from the front. So that's the front view and that's the top view. Just take a careful look at this, guys. We are starting from this point over here. Okay, so this is the point which is going to move around the surface of the cylinder. Let's start from this point and let's call this point as, let's say, well, what shall we call this point? Let's say this is P0, the 0 position, and the corresponding top view is going to be somewhere here. The point is going to move in this manner. The point is now here, so its corresponding top view will be somewhere here, isn't it? So that's going to be 1. So this is going to be P1. Then the point will be here. Okay, and now the corresponding top view of the point will be somewhere here. So this is going to be point 2. So this is position 2 of the point. Just take a look. This is the axial advance I'm talking about. This is the axial advance from let's say this is going to be from 0 to 2. From 0 to 2. In the same manner, the point is going to move further. Okay, going to move around the cylinder in this way, and its corresponding top view will be here. This is going to be point 3, then it's going to be in this position, then this is going to be called as point 4. Again, if you take a careful look, this is another axial advance. So what would you call this point? This is P3 and this is going to be called as P4. So this axial advance is, again, this is not AD, but let me just write this as, this is from AD is from 2 to 4. Earlier the advance was from 0 to 2. From 0 to 2, this is going to be from 2 to 4. That's it. Again, this is axial advance 1, not 2, let's say, and this is axial advance 1. Both of them are equal, aren't they? Right? So remember, the axial advance is going to remain same. It's going to remain same. So this is for 1/4 of the revolution, and this axial advance is also for 1/4 of the revolution. And if you move further, the points are going to be something like this. It is going to move around. This is going to be 5. This is 6. Behind the cylinder, you can say this is going to be 7, and finally, so that's P5, that's P6, and that's P7, and this is finally 1 revolution is complete. Let's say P8. So this can be written as 8. That's it. Okay. So this is how a helix can be perceived basically. So for first half revolution, that is between these 2 points. Between these 2 points, the distance traveled actually was AD Roman 1. Then between these 2 points, 2 and 4, this is the axial advance 2. Between 2 and 4, this was the axial advance. So this was attributed by Roman numeral 2. And if you take a look at further, this is going to be axial advance 3. Axial advance 3. Between 4 and 6. Between 4, this 4 and this 6, isn't it? In the same manner, you can work it out this also, between 6 and 8. All of them are going to be same. So for 1/4 of the revolution, it's same. For the next 1/4 revolution, again it's same. For the next 1/4 revolution, again this axial advance is same. And then for the final 1/4 of the revolution, again the axial advance remains same. AD remains same. And when this is so, the sort of curve that you are going to get is a helix. Now another important point with respect to a helix is pitch. Let me just show you what exactly is meant by a pitch. Here we go. And by the way, let us frame this curve. This is going to be visible to us between 0 to 4, but this portion is behind from 4 to 8. So that is not going to be visible, but ultimately it has to be given some respect in the form of a hidden line. That's it. So this is how a helix can be made. Okay. So for one revolution, the total axial distance displacement AD1, AD2, AD3 plus AD4, this entire summation is what is referred to as a pitch. Okay, the total axial advance for one revolution is referred to as pitch. And by now you must have understood what exactly a helix is. What are the conditions which are need to be followed? Number one, it should be moving around the surface of a cylinder. Secondly, with a uniform axial advance, and when that is so, the curve that you are going to get is a helix. Secondly, when you sum up all the axial advances, 1/4, 1/4, 1/4, 1/4, so you get the axial advance for one complete revolution. That axial advance is known by a very important term that is known as pitch. And whenever you come across the design of a spring, you will be required to know what the pitch is. Okay, apart from the other parameters in the form of wire diameter and the number of coils, the most important parameter is the pitch of any spring. And spring basically can be made from the foundation of a helix only. Okay, you'll be learning all of these things in the upcoming lectures. But for now, let us try to understand with the help of a very nice example as to how a helix can be constructed. And this is going to be for one convolution only. Now, if there are two convolutions, in that case, a helix can be made something like this. Let's say for one convolution, we had a curve like this. For two convolution, we'll have curve like this. Okay. So there are going to be two pitches. One pitch right here, one pitch right here. And both of them are going to be same, obviously. Let's kick off with a problem. And here we go. So draw a helix of one convolution upon a cylinder given 100 mm pitch is 100 mm and 50 mm diameter. Very simple. It's a cylindrical helix, first of all, okay, on a cylinder. You need to make the front and top view of a cylinder, and here it is. XY line. So the cylinder is actually seated on a horizontal plane, you can say. So the front view is obviously what you can say is a rectangle, and the top view obviously a circle. Let us divide the circle into 8 parts. You can go for 12 equal divisions also. I'm going to be doing this 8 equal divisions. You know how to do this. Okay, if you have been watching my lectures on engineering drawing, you know how to do 8 divisions. Very basic, 45-degree equal angles. Or you can use the bisection, angular bisection technique also. So let's mark the points right from here. Okay, now let us project lines from all these points. Let us make the front view. So the radius over here has to be taken as 25. Remember, the diameter is 50, therefore the radius 25. Height of the cylinder has to be taken as 100 mm. Okay, that is the pitch. So take it as 100 mm. Now what to do? Let us mark this point first of all. Okay, before that I need to project lines from these points. Something like this. Right? Now what to do? Let me mark the first point. Let us say, and this is by the way 100. Okay, let us say that this point is marked by point P0, you can say this. Okay, and this is the point which is going to move around the cylinder, right, forming a curve on a path that is in a way will be called a helix. Okay, but before that, what to do? Some other construction work has to be done. What we'll try to do, always remember, in case you are going for 8 divisions, so in this vertical line you have to go for 8 divisions also. So 100 divided by 8 is going to give you a decimal value. So instead what we'll do is that we'll use a line division technique. So basically, if there are 8 divisions of the circle, if the circle has been divided into 8 parts, then the vertical line here also has to be divided into 8 parts. I've seen in some books that they have gone for 12 parts. You can also do that, but in that case you make sure that this vertical line also has to be divided into 12 parts. It's absolutely up to you. Okay, so let's start. This is something which is known to you, I guess. If you have watched my lectures on plane scales, diagonal scale, this is very basic. Arcs of equal divisions, I would say 1 centimeter arc, 1 centimeter, 1 centimeter. How many? 8 arcs for 8 equal divisions. The last point has to be joined with the end of the line, this line. Okay, and then set your mini drafter along this line, tighten the screw, bring it over to the 7th point, draw a line, 6th point, draw a line, keep on doing so until all the points have been exhausted. Now set your drafter along this line, along this horizontal line, or set your drafter horizontally. Tighten the screw, bring it over here, here, and keep on doing so. And these are the horizontal lines that you are going to get. Let us start from, say, this point over here. Let's say that the point is going to start moving around the cylinder from here. Okay, and instead of writing P0 here, let me just put it, P0 is here, let's say. Okay, now start. This is 1/8 revolution. From P to 1, this is 1/8 revolution. So it would have moved by this much distance for 1/8 revolution, right? Okay, I already wrote that, so that has been written as P. Okay, so this is going to be your point P1. Okay, now we are here. In the top view we are here, in the front view we are here. The point has moved further from 1 to 2. So another 1/8 of the pitch will be covered. That means here, that is point P2. That means we have now reached point 2. The point is going to move further, 3. So in the front view it will be here. That is going to be P3. Now the point has moved from 3 to 4. That means in the front view it is going to be above 4. That is here. That is P4. In the same way you can work out the remaining points. That is above 5. That is P5. This is above 6. That is P6. The point will keep on advancing. Okay, that is P7, and finally this is your P8. Now you can say that one revolution is complete from 1, 5, 6, 7, and let's say this is a repetitive, let's say this is 8. Okay, so it has completed one convolution or one revolution, you can say, and in that case it has traced this curve. Let me make it. That is the curve it has traced. So this is in front, this is visible to us, and the one behind from 4 to 8 is not visible to us. That is why we are going to use a hidden sort of a dotted line, you can say, or a broken line. Not a line, but a broken curve, you can say. So this is exactly how a helix can be prepared. Okay, for a point moving around a cylinder, having uniform axial displacement or axial advance, you can say that. There is something else which I need to tell you. This is very interesting. Okay, let's do this. Okay, so my question to you is, just think about this. I'm pretty much sure that you must have gone through development of surfaces. So that's a cylinder. Okay, if you try to cut it open and lay it absolutely flat, listen to this again. If you try to cut the cylinder from this line, okay, with the help of a scissor, and you cut it open, lay it absolutely flat, try to comment on the profile of this curve. Will it still be looking like a curve, or will it become a line? Just try to think about this. Again, let me repeat my question. If you try to make the development of this cylinder, if you cut it open, lay it absolutely flat, what would be the status of this curve? Will it still remain curve, or will it become a line? The answer to that question lies in making the development. So let's do that. So when you cut open a cylinder, this portion is going to be your pi d, that is the circumference. Okay, I can even mark it pi d. Pi d will work out as 157.07, because when you do this pi d, 50 pi into 50, you will get this value 157.07. This is very basic. So we did 8 divisions over here. Okay, those same divisions will appear somewhere along this line also. So let me get rid of this dimension first of all, otherwise it is going to intersect. Now let us do 8 divisions over here, something like this, 8 equal arcs, let's say 1 centimeter arcs. This is the process. Let's start from here. Let's have vertical lines. Okay, let us try to mark this first point. This is going to be point P. We are going to start from here. Okay, that's it. All these things can be carried out very easily with the help of a mini drafter. I'm sure that you guys can do that. That's point P. So above 1 we have point P1. So above 1 we have point P1. Very easy. Above 2 we have point P2. Above 3 we have got point P3. Above 4 we've got point P4. 5 we've got P5. P6, P7, P8. That's it. P8 is above this point P. Very strange. So that means when you join all these points in proper sequence, what do you get? So the development of a helix, this is a very important question which can be asked to you for Viva examinations also. For your internal Vivas, what is the development of a helix? Okay, what is the development of a cylindrical helix? It's a line. Basically, it's a line. So guys, that was all from my side for today. I'll see you again in the next video. Until then, take care, have a nice day, keep learning, keep watching, and thank you.